Hi, we're going to start talking about quicksort, and as usual, we'll start with the idea of how it works. So the last sorting algorithm we'll study is the quicksort. It was developed by this British computer science named Tony Howe, I guess, in the late 50s and early 60s. And so it's one of the fastest sorting algorithm, if not the fastest. I actually think it is the fastest. Now, assuming that it is properly implemented, it's actually 2 to 3 times faster than some of the very fast sorting algorithm that we already studied, such as merge sort and heap sort. That's based on what Wikipedia says. So because of that, it is probably the most commonly used sorting algorithm today. And I believe like the Python's sorted function actually is implemented using shell quicksort. Okay, and so the basic idea of how it works. Well, it's sometimes called this, a partition exchange sort because it actually divides the input into two partitions. One partition has all the elements that are smaller than a pivot, and we'll talk about what a pivot is and does. And then the other partition has all the elements that are larger than the pivot. And once we have the two partitions, we'll use quicksort to recursively sort the two partitions. So it's a recursive algorithm. And now, what a pivot is, well, I mean, we just have to pick an element from the input to be the pivot. And there are many ways to pick a pivot. And a good choice of pivot is very, very important to the performance of quicksort, as we shall see. And we'll start with something simple. And that is, we'll just very simply pick the first element in the input as our pivot. So I'm going to show you kind of how it works now. So this is the input array of 8 numbers. And then the first thing we do, as we said, we pick the pivot. And again, in this case, we're going to pick the first element as the pivot. And then we're going to go through the entire input one at a time to figure out all the elements that are less than the pivot. Pivot is 4, so 2, 3, 1. They're all smaller than the pivot, and we're going to put it in one partition. And then we are going to put all the elements that are bigger than the pivot, 7, 9, 5, and 8, into the second partition. And then this second step is that we can do a swap of the pivot with the last element of the smaller partition. So we'll swap 4 and 1. And then what that does is that it put the pivot in the right place, right? So everything to the left of the pivot, they are still smaller than the pivot, and everything to its right, they are larger. So in a sense, this is sorted in a way that the pivot is in splitting the input is into a smaller partition and a larger partition. And now, obviously, if you look inside the individual partitions themselves, they're not necessarily sorted just yet, right? So then the next step we do is we just use quicksort recursively to sort the smaller partition and then the bigger partition. And then once that they are sorted, then the entire list is sorted. Okay, so there are some small variation to the way quicksort works, other than choice of pivot, which can be very different. But the small variation, one thing is that the certain implementation it doesn't do this swap, right? And instead of doing the swap at this step, it leaves the pivot where it is, and then it just sort the two smaller partitions, and then as the last step, it will reconstruct the input by putting the pivot in between the sorted partitions. And that's the way I remember how I learned it. But either way, the idea is extremely similar between the two approaches. So anyway, hopefully now you have a sense of how it works, and I'm going to ask you to try to use quicksort to sort the larger partition. All right, so hopefully you have had some time to work this out. I'm just going to quickly go through this now. And so what we do first thing is we pick 7 as a pivot, and then we partition the rest of the elements into the smaller partition and the larger partition, right? Now that the smaller partition, it has its only single element, we apply quicksort on it. It should quickly recognize that it's already sorted. Now we recursively sort the larger partition. In the larger partition, again, we pick the first element as the pivot. And then in this case, the only remaining element, 8, is smaller than the pivot. So we only have a smaller partition. And then remember, we actually do swap of the pivot with the last element of the smaller partition. And so we swap 8 and 9, and now this whole list is sorted. Okay, so hopefully that makes sense. I'm going to ask you to do one more exercise, and that is to sort the smaller partition from our previous example, just 1, 2, 3. And I hope you don't skip this, because it might not be as easy or simple as it might first appear, and it also hopefully show you why quicksort is actually not the best sorting algorithm if the input is small. So please go ahead and give this a try.